dogs. Every morning, I walk out, and this is how they sit and just stare at me. So it's a bit scary, but they're fine. 2 girls as well. I'm still debating who I like more. Yeah, and we'll be talking about AI.
Cool, and I'm Yossi Rachman. I'm the Director of Security Research for Semperis. I've been a security practitioner for the last 15 years, formally at least. I used to do some stuff a long time before. I'm a father of 2 ginger kids, one ginger husky who's probably trapped inside the body of a 40-year-old man because he likes fishing, and an extremely judgmental ginger cat. I'm colorblind, but I like orange apparently. And today we're going to talk to you about the big issue of the skill gap in the cybersecurity industry, and some attempts that we're making at tying in generative AI in order to try and mitigate that gap. So a couple of numbers. The global security gap, the global cybersecurity skill gap for 2021. Can anyone guess the numbers? How many people, how many unfilled positions on a global scale?
2 million.
2 million. All right. Raise it a little bit. A little bit more than that. 2 million and one.
Price is right.
Yeah. Any number wins.
+3.
All right. A little bit over that. So 3.5 million unfilled positions in 2021. By the end of 2025, the projections are that we'll have around 5 million unfilled jobs. That means there aren't enough human beings in order to close this gap, okay? And breaches are happening all the time. They're becoming more elaborate. They're becoming more dangerous. Their impact is becoming more destructive. That means that the only solution can come through technology, okay? And specifically through this guy. So, all right, not exactly this guy, but generative AI is a new technology. I'm sure all of you have heard about it. But attempts are being made at tying it up in order to come up with new solutions. Our paradigm is that this technology can be used in order to mitigate the huge skill gap that exists today in the cybersecurity field. We're going to show you a POC on how exactly we're trying to do that. And that's through one of our solutions, an already existing open source solution called Purple Knight, which Ran is about to tell you about, which we're baking ChatGPT capabilities into in order to exactly do that. Try and mitigate the cybersecurity skill gap.
All right, I'll preface the discussion about Purple Knight by saying that we're actually putting a lot of efforts into researching generative AI and LLMs in general in several different areas. This is just one of them. We consider this to be the lowest hanging fruit, and you'll see why. But actually, after we show you what we're doing with PK, then there's not a lot of us here, so hopefully we can have a discussion about other areas of research where we're doing a lot with LLMs that could be very, very, very impactful and can really change the way that we do security and that we do identity security. So stay tuned. We're going to show you some nice stuff, but then there'll be some discussions.
Can I ask a dumb question?
There are no dumb questions.
Repeat it for the mics. Could you explain what generative AI is?
Yeah, so basically, it's a large language model, meaning it has the capability to predict and come up with an outcome based on pre-learned data, huge amounts of data. And the biggest innovation in ChatGPT and additional generative AIs is the fact that it can both create content based on the data that was ingested into it and analyze the context from existing data that's being given to it. So we're going to dive into it a little bit later on. But basically, think about a 6-year-old kid with a lot of imagination, with extremely good acting talents, that also has, let's say, almost all of the online information that humanity created until September 2021. That's what we're dealing with.
I think what you're asking is about the word generative. Why is it called generative? So the model doesn't know what it's going to say until it's up to the next word, right? It's statistically only predicting the next word. It doesn't know, it doesn't have a concept in mind, and then it's filling in kind of what it wants to say about the concept. It's word by word, what is statistically in vector space the nearest word to the last word based on the context that it was given, right? And I've seen a lot of different thinkers say that that's kind of the way that we work, right? So we have some kind of concept in mind, but we don't really know what we're going to say until that next word comes up, right? And in our minds and in these types of models, then the, I guess, the nearer a word is in vector space, right, in X dimensions, the nearer it is in concept space. So it's kind of, it really does simulate in many ways how we think and how we talk, which is why, you know, we talk to ChatGPT and we think we're talking to a person.
Now, if you think about it, one of the outcomes is the fact that ChatGPT and other LLMs invent stuff. Okay, they lie without knowing that they're lying. Obviously, they don't have any self-consciousness. They hallucinate, meaning they describe a reality that doesn't necessarily exist. If you translate that to actual technical examples, then sometimes if you're asking for bytes of code from ChatGPT and other LLMs, they'll invent code libraries that don't actually exist. So a lot of effort goes into fine-tuning the question and the follow-up questions. That entire field is called prompt engineering, in order to come up with an actual useful answer.
And that's where we spent most of the time on this research, is how to minimize hallucinations and to come up with a way to kind of QA. It's a whole new method of doing QA, right, of testing. Making sure that the results that you get within a given context and within a given prompt or prompt space, because as you'll see, it's not just one prompt, but it's a series of prompts that leads a user through kind of a journey with the LLM to get the desired result, right? So dealing with this is what we spend most of the time on, and what we're now spending most of the time on is how to minimize hallucinations and get the right type of output from these capabilities. Okay, so let's talk a little bit about Purple Night. Who here is familiar with Purple Night at all? Okay, so some of you know what it is. So Purple Night is really our attempt to democratize AD security in a way. So it's a free tool that's out there for anyone to download, and it's very, very simple to use. It's next, 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 and it scans AD, no special privileges required, just runs about 120 different scripts to find misconfigurations, indicators of exposure in Active Directory, also in Azure AD, and in their combination, right, hybrid environments. And it'll spit out a very nicely formatted report, very actionable. Here's what you need to do. It'll give you a grade, right? So you've got a D in your AD security. Again, the goal here, the understanding was that there is this knowledge gap. Not a lot of people know about AD, but a lot of people have AD. A lot of companies have AD, and they need their AD is crap, right? And they need to fix it. They need to make it better. They need to improve their security posture. So that's what we came out with Purple Night. So to kind of summarize that, when we get the report, but then we need to understand the findings, right? And then we need to do the impact analysis to figure out what happens if what do I break if I remove this permission? What happens if I do the remediation? So
yeah, so basically what we did was take Purple Night, and then we said we want to democratize the ability to understand the vulnerabilities and to mitigate them, to fix them even more. And the way to do that was through the integration of specifically ChatGPT, but basically a lot of other LLMs are also capable of doing the same work. The idea is to provide the same capability even to the smallest of teams, okay? Meaning, in order to fix something, in order to understand the impact of something, in order to understand the actual vulnerability, you can have just one guy at your team, okay, using Purple Night or DSP additionally, or other platforms that will have, which will integrate ChatGPT with, but using it through the force multiplier that is ChatGPT. Now we're going to show you the POC in a second, and please bear with us because we we did not pray to the gods of demos this morning, so stuff could break. But let's just hope that karma holds tonight.
Let's see if it works.
Yeah.
Really, contextualization of prompt is key, right? You need if you just ask GPT, kind of, what does this mean? It might throw out an answer that's a page long. You might not understand it any better. It might not even be any better than kind of the generic text that we already have. But then when you start to refine the prompt, when you start to imagine you're a CISO, or imagine you're a security analyst, or imagine you're just someone off the street. Now explain to me in 5 sentences what's the biggest risk, right? Things like that. And doing that and being able to make those prompts more generic and then just parameterize kind of the context, the specific context, whether it's the indicator or the specific vulnerability or something like that. That's kind of the secret sauce.
All right, cool. So that's Purple Knight. That's the actual product. Again, it's open source. You can find it online. You just need to hit the download button and you can just run it. But the way it's built is once you run it, you're provided with a score saying this is the situation in terms of your security posture.
Nobody gets a 99%.
Yeah, nobody. Only AI. What are your critical findings? What are your high-risk findings? And so on and so forth. And then you've got the actual name of the findings and the severity level and so on. Now, if we jump to something like DPAPI, how many people here are familiar with it? Know what DPAPI is? All right, awesome.
Except Guido and Darren.
Yeah, which are Semperis people, so yeah. So anyway, it's a finding. You see, it's a medium risk finding. There's a warning around it. You want to read some more data into it. There's a description here, but in order to actually understand what it does and what's the impact, you'll have to Google a little bit, maybe go into Stack Overflow and stuff like that. So basically what we've done was add this button, which in the end version of this product will have the entire indicator already populated here.
This is a POC, by the way, so this is not something you're going to see in the market tomorrow. It's still going to take it a while.
Yeah, and by the way, we call it Copilot because PK stands for Purple Knight and Copilot, like Microsoft's Copilot. So anyway, yeah, you hit send, and then you choose whether or not you want the CISO or the analyst to actually get the data. So if it's a CISO, we'll have like a higher level description of things, how to mitigate, what it does exactly. Let's review it right now. And you've also got a free text box here where you can actually ask questions based on the data that the ChatGPT engine provides you with. It's thinking right now. It takes a couple of seconds. All right, so basically, because it's a CISO level, kind of security executive level, it says those are the domains that are relevant for that specific finding. That's the purpose of the indicator. It can be formatted a little bit better, but the idea here is to provide data that actually explains in high level what's the problem here. And you can also ask GPT to shorten it. So once it finishes, I'll ask it to
An important point here, by the way, to understand is that the prompt is not asking about DPAPI. The prompt is actually feeding the indicator source code to ChatGPT, right? The indicator source code and libraries that we use for the security indicators. So it's actually analyzing the exact tests that we're running. So it's going, and you could have seen in the text there, it's telling you what the indicator is doing, and it's telling you what DPAPI is, and it's telling you the risks. Right, a lot of our indicators could be more complex, right? We've got certificate indicators and other things, and it's very good at analyzing that code and actually telling you what the indicator is doing, as opposed to just looking at a better Google search of something.
Yes, and thank you, Ran, for stalling while the demo started.
What broke?
Yeah, broke, but we'll fix it in a second.
One question is we hear a lot about ChatGPT going out and being basically public, so the data is going out and searching. So is anything of our information about what we have going to ChatGPT?
Absolutely not.
Being published?
Our whole approach here was that data privacy is paramount. We're not sending anything to ChatGPT. We're just providing ChatGPT with the actual description and technical description, basically, around the indicator itself. No data, no environmental data, nothing from your own environment, no IP addresses, host names, SPNs, nothing gets sent to ChatGPT, and that's this specific version. In follow-up versions, we aim to use the Microsoft OpenAI GPT in order to basically utilize their privacy settings. So even when data is supposed to be sent, which we're not going to do because we're dealing with extremely sensitive data, this data shouldn't be used for teaching the LLM model, additional stuff.
So I mentioned before, we're looking at it at several different levels. This is kind of the low-hanging fruit. This is the generic ChatGPT. We're not sending any specific contextualized data, right? We're feeding it the indicator source code, which is open source anyway. You can find it on the internet. We're feeding that to ChatGPT, and we're asking generic questions. Generic prompt, you can also modify the prompt. What Yossi was referring to, what we're also looking into, is utilizing Microsoft's Azure GPT, right? Their implementation. They have their own privacy policy that says that data you sent is only part of your specific tenant private model.
So it doesn't go out of our territory.
It does not. It's not used to train the foundational model, like the base model that's being used. And that's what we're experimenting there is with the possibility of over time, as you run this through our commercial software, it learns over time what your environment actually looks like, right? And we take that to do impact analysis, right? So if I turn this specific configuration off, what might break, what might not break. We also feed it with, if anyone's familiar with Forest Druid data, right? So attack path analysis, an identity graph, permissions graph. So it really understands, it has a very deep understanding of where every single permission goes.
So it'll go back to that graph from Druid and stuff.
Yeah, and you'll be able to talk to it. So it's not, if anybody's familiar with Forest Druid, right now you get a graph on the screen and you have to kind of analyze it. We have our own algorithms to do risk analysis, so you have a score there. But it's very difficult to make sense of, okay, I have this attack path. What does it actually mean? Tell me a story about this attack path. Tell me a phishing story about it, right? So an attacker phishes someone, they get access to this app, they can hop over that, privilege escalate over there. That's something that an LLM can do, right? And that's what, but it needs a lot of context to be able to do that in a way that actually makes sense. And right now, we're at the point where we're able to get these very coherent stories about very specific attack paths in a very specific context, which is amazing. And then the next stage, and Yossi's going to show like the first real part of that is mitigation, right? So,
Just a question
yeah,
on that.
sorry.
Sorry to go back. So, adding context. Would we be able to add in our own control stack?
That's the goal.
Yeah.
Which would then be able to provide context around the remediation, because
Yes.
I hate it when you get these remediation efforts back and you're like, okay, now I've got to read through
Yes.
what's relevant and what's not, because I've got this layer, this layer, this layer that's compensating control against that finding.
Yeah.
Like, give me what are the gaps based on what my current stack is.
Yeah, absolutely. And that's the whole intention of why we want to use the Microsoft OpenAI ChatGPT, because then through the privacy settings, you can make sure that the data that you're sending in order to come up with the analyzed context, okay, that data isn't being sent to Microsoft servers for analysis. That data won't be used by other third parties or whatever. Once we have confidence that actually exists, that limitation actually exists, then we can use the analysis of your own environment to provide you with actual contextualized mitigation, not just general mitigation.
But if we're gonna sign our own agreement, right? So say we're moving down the path with OpenAI and we're gonna sign an enterprise agreement with them to have our own tenant.
Yep.
Are we able to deploy this within our own tenant, or this is gonna be something that we leverage? It's in your tenant.
So
The goal of this is to leverage your existing tenant, because we realize that you're going to have your own model.
Yeah.
You're going to have your own model. That's where this seems to be going, right? You're going to have your own model that sits above the foundational model.
the next phase, because our own product sits in any node, basically meaning any change you make to your Active Directory state or Azure Active Directory, we're already aware of it, then we can ingest that into the model without you having to do anything. So once you provide your next query, that data is already updated with the most recent changes you've made.
And we've already been able to get very, very good mitigation scripts, PowerShell mitigation scripts. We've reduced hallucinations down. We're getting very good results with GPT-4, not 3.5.
Yeah.
Because of the token size, by the way, because it needs a lot of context to do the scripting right. But then really, exactly, the next part of it is how do you make this mitigation script relevant to the controls that you have, to your environment? That's the next step. That, by the way, is not going to be part of Purple Knight. That's going to be part of our commercial offerings, of course.
Because then I think there's additional things that you can think of there, right? It's not just that you have a technology, it's like, well, what are the configurations that you've got, what are all the rules that you've got built into it? Because just because you have tool X doesn't mean you're going to be remediating all of the issues that come with it.
Absolutely. And maybe, you only want to focus on specific areas in your environment. Okay, you don't want to have the model relearn your whole environment again. So, that's like next phases, but obviously the pricing model will also take that into account, the size of your environment and which areas you're focusing on. Cool, so what we're seeing on screen right now is the actual mitigation script. Meaning if we previously had sorry about that. All right, so if we previously saw the description of the actual vulnerability or finding, here we've asked ChatGPT to provide us with the actual mitigation script. And that mitigation script is tailored to that specific environment. Basically meaning you can copy paste this whole area, run it, and that vulnerability will be fixed. So you've got a product that can be used by the CISO, by the security executive, and by the security analyst, all from the same screen. You don't have to print any reports. You don't have to summarize any executive reports out of a technical report. It saves tremendous amounts of hours for analysts, and I don't know any analyst who likes writing reports, okay, or making PowerPoint decks. And you can just hit a button, show it to the CISO, and then give back the screen to the analyst so he'll be able to fix the indicator itself. Cool. Any questions?
I think the hard part on this is in any typical Active Directory environment, an account can be used in any number of unknown places in the environment that you may or may not be able to easily discover. So ACLs on file servers, service accounts for a particular business application.
Yep.
The impact analysis is the hardest part. I've seen, Microsoft comes out and does these 80 wraps where they'll go in and assess your AD and tell you a laundry list of things to do. And most organizations I've seen pretty much have to ignore that because they can't possibly do most of those things because of the impact to the environment.
Yeah.
And that's a hard problem to solve. If somebody can figure that one out, that would be amazing.
So we can start by highlighting the impact. Saying, if you touch that, if you disable a user account or, I don't know, maybe even delete service account or whatever, those are the repercussions. That's the chain of consequences that's going to happen. We're already sitting there. We have visibility to the data. The only thing that's missing is ingesting it into our LLM model, large language model, and then using that as the UX to actually come up with the answer, with the actual impact analysis. So human trying to create a system that will be able to understand the exact impact is a very heavy lift, but because we already have the data and we can ingest it into that model, then with some, let's say, fine-tuning of the actual question and the prompt engineering that's involved here, we should be able to come up with the answer. Yes?
So here using things like your BSP events, it's going to look at who may be accessing that particular object, the attributes, and perhaps making changes. Therefore, if you're restricting rights that are overly open today, it would be able to tell us these are the accounts and this is who owns the account.
Yes.
That may be impacted by what you're doing. Is what you're saying.
Not necessarily accessing initially, since we're looking at the directory service.
Commercial product when you're integrating it with,
Yep.
with the rest of that data.
Once you start including the authentication logs, right, then you can start to see the access. right? Initially, we'll be looking at the exposures and vulnerabilities. We'll be looking at the identity graph, and we'll be looking at the change history, right? Of whether it's on-prem AD or Azure AD or the future
When
Okta.
you're looking at the authentication logs, are you going to be looking at where they're logging in from, what they're logging into, and the protocol being used?
Yes,
In
and
the
also
future.
how far back.
Okay.
Yeah, so basically, for the open text box here, you can limit how far back we look at the data, saying only provide me with data that's relevant for the last, 5 years. Anybody who authenticated using that service account 6 years ago.
It's keeping it in SQL. 5 years worth of my data in SQL. SQL doesn't support a database that big.
All right, that depends on your environment, I guess. But yeah, you can define the specific.
Yes.
That's a discussion for happy hour tonight.
Yeah,
About your yeah.
totally.
Well, I heard Mickey talk about maybe looking at some changes.
Let's talk about that.
Yeah. All right, cool. Any more questions, guys?
I have a question. Yeah,
Yeah,
go
I
ahead.
think-
Sorry.
Well, regarding the QA you were talking about and driving down the number of hallucinations, I guess I was just curious,
Mhm.
what's the thinking around as that number theoretically approaches zero, but doesn't reach zero? How do you mitigate kind of, especially as the output gets more complex,
Yep.
like the outputs on scripts and stuff
Yeah.
that we have, how do you mitigate those, say, 1 in 100 or 1 in 1,000 cases where the line output?
That's a great question.
So let me start by saying that's the secret sauce.
Yeah.
But so basically, what we did here, we've got like a limited list of indicators, around 150, 120 more or less. And because we're the ones who created them, we know exactly what's the expected output. Now, it doesn't mean that we've authored the answer, okay? But we know enough so that we ran on each and every indicator. We know what's the spectrum of error, what's the range of error. So based on roughly around 150 indicators, the hallucinations are minimized to almost zero. And as we add more indicators, and as environments become more and more complex, that will be our job in the security research department to make sure that the hallucinations are minimal.
So there's two parts to this, as we see it right now. One, as I mentioned before, it's revolutionizing how we do QA, right? Whether it's, and we have a researcher looking into this right now, maybe how to use AI to QA AI, right? That's number one. Number two is today when we write indicators, and this is true for the entire industry, right? You write an indicator that has code, and then you write metadata for the indicator, descriptions and so on. That metadata will include a prompt template, right? Whose purpose is to reduce hallucinations. So it's the combination of those two things. And that's why, at least as I see it, it's not going to be automated initially, right? It's not going to create a mitigation script and just run it. There'll have to be some oversight, some kind of change management process there. But over time, I think we'll get to a point where a lot of that response capability is just going to be automated.
And I can tell you one more thing. While we were building the prompts themselves, we actually asked ChatGPT not to lie. That's actually one of the prompts that we've provided it with. And it said okay, so we can.
Is that like asking a kindergartner not to lie?
Oh yeah, that's why I said it's like a 6-year-old. Yeah.
A kindergartner that has read the complete internet until 21.
Yeah. Cool, awesome. That's our bell.
That's our
bell.
bell.
So thanks everyone.
Thank you.